Hi,
مرحبا أستاذ.
keep going.
هلا أستاذ.
Okay. Yesterday and the day before, we took how to prove convergent, or we took the definition of convergent. We took how to prove the sequence is increasing or decreasing. Now today we are going to start with the principle of reasoning by recurrence, or we call it mathematical induction. Don't try it for 1 minute. Principle of reasoning by recurrence or mathematical induction. In which case we use this method. It is a method to prove a relation depending on a natural number n. So whenever we need to prove a relation depending on a number n is always true. This method is composed of 3 parts. Verify the relation is true for the smallest value of n. Verify that this relation is true for the smallest value of n. Second step, we suppose that the relation is true for n. And third step, prove that this relation is true for n plus 1. So mathematical induction is used whenever a relation that depends on n, and we are going to prove that this relation is true for whatever is n. We have 3 steps. We verify that this relation is true for the smallest value of n. We suppose that the given relation is true as a second step. Third step, we prove that this relation is true for n plus 1. You understand or you don't understand? هذا definition. Can I skip this page?
1 minute أستاذ اكتب. Done أستاذ.
Okay, now we are going to take some examples. So whenever we have a relation that depends on n, and we need to prove this relation is true whatever is n, there are 3 steps. First step, you have to prove that this relation is true for the smallest value of n, or any value of n. Second step, we suppose the given relation is true. Third step, prove that this relation is true for n plus 1. Example 1. Please don't write. Don't write and listen, and I will give you time to write, okay? Example 1. Don't write, Bijaa. Prove using mathematical induction that the sum of numbers from 1 to n is n into n plus 1 over 2. This relation depends on n. I need to prove this relation is true for any value of n. Yani if I need to find the sum of numbers from 1 till 100, it will be 100 times 101 over 2. I have to prove. So there is mathematical induction. مثل قلنا mathematical induction, we have 3 steps. Hide the first step, don't write. So the smallest value of n is 1. For n equal 1, I take the first number here, 1. For n equal 1, I take the first number here is 1, and here I replace n by 1. 1 equals 1 into 1 plus 1. I replace n by 1 over 2, so 1 equal 1. So this relation is true for the first value, for the smallest value of n. So for n equal 1, I take the first number on the left, and I replace n by 1. Second step, suppose that the given relation is true. Suppose that 1 plus 2 plus n equal n into n plus 1 over 2. Step number 3, we are going to prove, let's prove that this relation is true for n plus 1. So whenever I need to prove this relation is true for n plus 1. So I replace each n by n plus 1. The left side becomes 1 plus 2 plus n plus n plus 1. The right side will become n plus 1 into n plus 2 over 2. Any questions still here? I need to prove this.
الفيرست second step بس بالآن نعمل مثل ما هو.
So second step, you suppose this relation is true.
Oh,
You suppose
أستاذ
yes,
أستاذ
yes.
ليش هونيك n n plus 2 ومش n plus 1 times n plus 1.
I replace each n by n plus 1. هيدا بتصير n plus 1.
اوكي
هيدا بتصير n plus 1 plus 1 يعني n plus 2.
اوكي
Okay, I need to prove this. So I take the left side. I take the left side of the equation. I take 1 plus 2 plus n plus n plus 1. هذا left side. 1 plus 2 plus n is here from this one. 1 plus 2 plus n, I suppose it is equal n into n plus 1 over 2. N plus 1 remains n plus 1. I take the LCM, or I take n plus 1 common factor, n plus 1, n over 2 plus 1. We take the LCM here. It's here n plus 1 into n plus 2 over 2, which is true. So it is proved. 1 plus 2 plus n plus n plus 1, here n plus 1 into n plus 2 over 2. Finally, the given relation. Yes, Haikaz, what did you say? Haikaz, what is your question? Where here? Here? Third line here? Which line?
Yeah, third line. The 1 plus 2 plus n plus n plus 1. Hey, n when
I replace it here before n. What do you have before n, Haikaz, here? What is the term that precedes n?
n.
N minus 1, yes? Before n, n minus 1, say?
Ah, yeah. Yeah.
If you replace n if you replace n by n plus 1, you will get n.
Merci.
Okay, whenever you finish writing, tell me to take another example. Can I skip this page? Because
1 second sis.
okay, I'm أهلك.
أستاذ بس in this case بناخد بدل n plus 1.
In all the cases, mathematical induction, I go back. أول شيء, step 1, you verify this relation is true for the smallest value of n. Second step, you
Okay.
suppose the given relation is true, and you prove this relation is true for n plus 1. In all cases, whenever we need to use mathematical induction.
Done sis. Merci.
Okay, please don't write and listen. Okay. I have example 2. Consider the sequence un defined by un defined by u0 equal 1, un plus 1 equal 9 over 6 minus un. This one is called a recurrent sequence. Proving by mathematical induction that un is between 0 and 3 for every n. un is between 0 and 3. Don't write and listen. راح اعمل بروف غير هيدا شوي difficult هون. راح اعمل غير another proof. Please, first I have to prove first that un is greater than 0. un greater than 0. I have to prove it by mathematical induction. First step, I have u0 equal 1 is greater than 0. So this step is true for the first step. تاني part, suppose un greater than 0. Show that شو نمبر هنا هلا show that what is the step اللي بعد هيدا show that un plus 1 greater than 0. How to prove un plus 1 greater than 0? What is un plus 1?
Is u1.
un plus 1 is 9 over 6 minus un. What is the sign of 9 over 6 minus un?
أو positive أو negative.
Yes. أنا معنى UN greater than 0 مش هيك؟
إذا UN greater than 0 يعني بيصير negative sign تبع UN plus 1.
UN is greater than
No.
0. يعني minus UN negative. يعني 6 minus UN 6 minus UN is less than 6. So I can here start 1 over 6 minus UN is greater than 1 over 6. So 9 over Okay, I will repeat step by step. Since I need to prove that UN is greater than is UN between 0 and 3, I have to prove UN is greater than 0 and UN less than 3. Okay, شباب, I have to prove UN greater than 0. For this step, I use mathematical induction. أول step, it is given that U0 equal 1, which is greater than 0. Suppose that UN is greater than 0. Step 10. Step 30, I have to prove that UN plus 1 is greater than 0. UN plus 1 here, 9 over 6 minus UN. I have to prove it is greater than 0. I have to prove this one. So, what I have, UN greater than 0. Since I have here minus UN, I multiply by negative. Negative UN will be less than 0. Since I have 6 here, I add 6 to each side. 6 minus UN less than 6. I make the reciprocal. So now 1 over 6 minus UN greater than 1 over 6. تذكروا framing from grade 10 كيف إجا 1 over 6 minus UN will be greater than 1 over 6. I multiply by 9. It becomes 9 over 6, this one. So UN plus 1 is greater than 0. Any questions about the first part? How we prove that UN is greater than 0?
أستاذ قبل آخر ستيب شو
Yes.
عملنا؟ قطع شوطك ما سمعت قبل.
Here I make the reciprocal. 1 over 6 minus UN is greater than 1 over 6. If I have 2 less than 3, إذا عملت 1 over 2, it becomes greater than 1 over 3. I multiply by 9 to get 9 over 6 minus UN greater than 9 over 6. So UN plus 1 is greater than 0. Second step, I have to prove that UN less than 3. I need to prove this one by mathematical induction. أول step, I have U0 equals 1 less than 3. Suppose UN less than 3. Suppose show that step show that UN plus 1 less than 3. What is UN plus 1? Is 9 over 6 minus UN. Since I have UN less than 3, minus un greater than minus 3. 6, I add 6. 6 minus un greater than 3. 1 over 6 minus un will be less than 1 over 3. Multiplying by 9 the two sides, 9 over 6 minus un less than 3. It means that un plus 1 less than 3. So un is between 0 and 3. You can write if you have no questions.
أستاذ un plus 1 is less than 3 بعدين
So un is
كيف؟
less than 3. I need to prove by mathematical induction. I have to prove first un less than 3. The mathematical induction to prove this relation is true. 3 steps. أول step, I have to prove un less than 3. First step, you prove that this relation is true for the smallest value of n. u0 equal 1 less than 3. Suppose un less than 3, second step. Step 3, we have to prove that un plus 1 less than 3. I have to prove at the beginning that un less than 3. I have to prove this relation that depends on n is true. To prove it is true, if the 3 steps are satisfied, then we get un less than 3.
أستاذ بس نكتب solution اللي كتبت أنت مو؟
Yes. Because did you finish? Because
Yes. خلاص أستاذ.
is it okay? Example 3. Let un be the sequence, be the recurrent sequence defined by u0 equal to and un plus 1 equals 2un minus 3 for every n greater than or equal, for every n greater than 0, not greater or equal to 0, greater than 0. Greater or equal, okay. Part 1, how to calculate u1, u2, u3, and u4. Who can tell how to calculate? How to calculate U1? How to calculate U1? From this relation, what will be U1? إذا حطينا محل الآن 0 شو بصير هذا الريليشن؟ يصير عندنا U1 equal to U0 minus 3 equals 2 into 2 equals how much? For n equal 1, U2 equals 2U1 minus 3
بنحط
equal
1
minus 3 equal minus 1. For n equals 2, U3 equals 2U2 minus 3 equal 2 into minus 1 minus 3 equals minus 5. For n equal 3, U4 equal 2 U3 minus 3 equal minus 10 minus 3 Any questions?
No.
Now, part 2, show that UN equals 3 minus 2 to the power n by mathematical induction. هذه for n belongs to n star بدون 0. To prove by mathematical induction, we have 3 steps. First step, we prove that this relation is true for the smallest value of n. For n equal 1, U1 equals 3
smallest value مش 0
هون لازم يكون n belongs to n star يعني أصغر value هي 1. Okay. For n equal 1, I have to prove U1 equal 3 minus 2 to the power 1. U1 لأين is 1. 1 equal 1. It is true. هاي أول step. Then step, suppose the given relation is true. Suppose UN equal 3 minus 2 to the n. show that step 3, show that un plus 1 I need to prove that un plus 1 equal, this one is, we have to prove it. احنا معنا what we have un plus 1. احنا given un plus 1 equal how much? Equals 2 un minus 3 equals to un, we have its value is 3 minus 2 to the n minus 3. Expand. 2 times 3 is 6. Minus 2 times 2 to the power n plus 1. 2 times 2 to the power n. We add the powers. This is 2 to the power n plus 1 minus 3. We get 3 minus 2 to the power n plus 1. Therefore, un is equal 3 minus 2 to the n. un
هون شو صار أستاذ؟
which one?
هاي un plus 1
This one, un plus 1, we have it from here. Shift from home. I need to prove that
Yes.
un plus 1 equals 3 minus 2 to un plus 1. But now un plus 1 is 2 un minus 3. Okay, I had a given. And I
Yes.
replace un by its value. This is un. I replace
كتبت أستاذ.
okay, the last part, how to calculate u10, part 3. How to calculate u10.
بنحط بهيدا equation un equals 3 minus
نعمل 3 minus 2 to the power of 10.
3 minus 2 to the power 10. بتلاقوا قديش 2 to the power 10 and you calculate the answer. Okay, this is all for today. We'll continue on Tuesday.
واحد بس هاي هالقد.
You calculate using the calculator 3 minus 2 to the power 10.
Yes. Bye أستاذ. Have a nice weekend.
Bye bye. See you.
يلا باي.
Bye bye.
Bye.
يلا باي.
Bye bye. Bye.